You think you know what you're asking when you ask, why do magnets repel? You really think you know, but you don't. And until you understand why your question itself is broken, you're going to be frustrated by every answer anyone gives you, including mine. Let me show you the problem. Pick up two magnets, North Pole to North Pole. Feel that push, that resistance, that invisible pressure in what looks like empty air. You want to know why? You want me to say magnets repel for the same reason that, and then fill in the blank with something familiar. Rubber bands, springs, two hands pushing against each other, something you already understand, something comfortable. But here's there is no familiar thing. And I'm not being difficult, I'm not being clever, I'm not hiding behind complexity. I'm telling you the truth, a truth most people don't want to hear. Magnetic forces are fundamental, they're rock bottom, there is nothing underneath them. You're asking me to explain electromagnetism by comparing it to something simpler. But there isn't anything simpler. That's like asking me to explain arithmetic using something more basic than numbers. It just can't be done. Now you're probably thinking, wait, I've heard explanations. Magnetic fields, electron spinning, field lines, flux. Those sound like deeper explanations. They're not. They're descriptions, very precise, very accurate descriptions. They tell you how the force behaves, not why it exists in the first place. And if you don't understand the difference between those two things, then this entire conversation is pointless. Let me ask you something. Push your hand down on your desk right now. Go ahead, push hard. Why doesn't your hand go through? You'll probably say, because the desk is solid. That sounds like an explanation, but it isn't. It's just another label. Try again. Why doesn't your hand pass through the desk? Because the atoms are packed together better. Keep going. Why don't the atoms in your hand pass through the atoms in the desk? Because atoms are solid? No. Stop. Think. Atoms are not solid. An atom is mostly empty space. If you scale an atom up to the size of a football stadium, the nucleus would be a tiny pea at the center. The electrons would be little dots far out near the seats. Everything in between is empty. Your hand is mostly empty space. The desk is mostly empty space. So why don't they pass through each other? Good. You're uncomfortable now. You should be. The answer is electromagnetic repulsion. The electron in your hand and the electrons in the desk have the same electric charge. Like charges repel. When you push down, you're feeling trillions upon trillions of tiny electromagnetic interactions, adding up to what you call solid. Now here's the question that really traps you. Why do like charges repel? You can't answer that. You can say electromagnetic force, but that's just naming the thing. That's not explaining it. That's like asking why magnets repel and answering because of magnetic force. It's circular. Electromagnetism is one of the four fundamental forces of nature. It isn't caused by something else. It isn't derived from something deeper. It just is. And here's what nobody tells you. The force that stops your hand at the surface of the desk is the exact same force that makes magnets push apart. Not similar, not analogous, identical. The electromagnetic force. So why does one feel obvious and the other feel mysterious? Because of your brain. You've been pushing on solid objects since you were a baby. By the time you were 2 years old, your brain had built an enormous library of experiences, pushing, grabbing, falling, hitting the ground. Your neurons wired themselves around those experiences. They built intuition. So pushing on a desk feels normal, natural, obvious. It doesn't feel like something that needs explaining. But magnets push through empty space. You can see the gap. You can slide a piece of paper between them. That feels wrong. That feels strange. That feels like it needs an explanation. But the weirdness isn't in the physics. The weirdness is in your psychology. When you push on a desk, the electrons in your hand never actually touch the electrons in the desk. They repel at a tiny distance, just a few atomic widths, too small to see. So we call it contact. But nothing is actually touching. With magnets, the distance is larger, a centimeter, an inch. Big enough to see, big enough to bother you. Same force, same mechanism, different scale. That's the only difference. You don't get real understanding from a 5-minute explanation. You just don't. You get it by working with the mathematics, by solving problems, by making calculations, by predicting outcomes and then checking whether reality agrees with you or not. After months, sometimes years, of working with electromagnetic theory, some changes in your brain. The equations stop feeling foreign, they start to feel natural, obvious. Not because they match everyday experience, but because you've built a new everyday experience, a mathematical experience with how fields behave, how forces scale with distance, how systems move toward lower energy states. And when that happens, magnets stop being mysterious. They become inevitable, exactly what you'd expect once you understand charged particles and fields. But you can't shortcut that process. You can't skip to the end. You have to earn the intuition. Now let me tell you what I can give you, the technical answer. Magnets have magnetic dipole moments, little arrows of magnetism. When many of them are aligned in the same direction, you get a permanent magnet. Those dipoles create a magnetic field configuration that stores potential, energy. And here's an important principle of physics, physical. Systems naturally evolve towards states of lower energy. When two north poles face each other, the energy of the system is high. Moving them apart lowers the energy. So they repel. That's the answer. That's as deep as it goes. You want to know why dipoles create fields? I can tell you about moving charges and electron spin. You want to know why electrons have spin? I can tell you about quantum mechanics and the Dirac equation. You want to know why the Dirac equation is correct? Because it follows from combining quantum mechanics with special relativity. You want to know why those theories hold? Because they match reality. Because we've tested them millions of times and they work. That's it. That's where the chain ends. This is what you need to understand about how physics actually works. We don't start with philosophy and derive the universe. We start with measurements. We observe patterns. We write equations that describe those patterns. We test those equations against new experiments. When the equations keep working, when they predict things we haven't seen yet, we say we understand the phenomenon. Understanding in physics does not mean philosophical satisfaction. It does not mean comfort. It does not mean matching your intuition. It means predictive power. By that standard, we understand electromagnetism extraordinarily well. Quantum electrodynamics is tested to incredible precision. We can calculate the magnetic moment of an electron to 11 decimal places. An experiment agrees exactly. So when I say I understand magnets, this is what I mean. I can calculate the force between them. I can predict how they'll behave in different configurations. I can design electric motors, generators, MRI machines. I can manipulate magnetic fields to trap particles or focus beams. That's real understanding. That's what physics offers, not comfort, not familiar. Analogies. But power, control over nature. You might not like this answer. You might find it unsatisfying, tough. The universe doesn't owe you an explanation that makes you comfortable. It doesn't owe you a story that fits your intuition about how things should work. Your intuition evolved to throw rocks, pick fruit, and avoid predators. It did not evolve to understand quantum fields or electromagnetic interactions at atomic scales. So when physics shows you something that violates your intuition, particles acting like waves, time slowing down at high speed, magnets pushing through empty space, you have two choices. You can reject it as mysterious and keep asking for better explanations that don't exist, or you can expand your intuition, learn the mathematics, work through the problems. Build new mental models based on equations and experiments, not everyday experience. That's what physicists do. None of us found quantum mechanics intuitive at first, but we worked with it long enough that it became familiar. Eventually, it started to feel natural, not because it matches common sense, but because we built new common sense, mathematical common sense. So here's what I want you to take away from all this. The next time you pick up two magnets, TS, and feel them push apart, don't ask why, ask how. How does the force depend on distance? How strong is it compared to gravity? How can I calculate it? How can I use it? Those questions have answers, good answers, precise answers, beautiful answers. The why? Question. The one asking for reduction to something more familiar. doesn't have an answer. Not for magnets, not for any fundamental force, because fundamental means exactly that, bottom level, nothing underneath. But here's the beautiful thing people miss when they get stuck on. Why? Physics reveals that the universe operates according to a small set of rules. The same equations that describe magnets also describe lightning, brain signals, computer chips, the northern lights, chemical bonds, why stars shine, and why atoms are stable. That's not a failure to explain. That's unification. That's discovering that beneath all the apparent complexity and chaos of nature, there's a deep structure, a mathematical structure. Simple rules with incredibly complex consequences. You wanted me to explain magnets by comparing them to something familiar. But here's something better. Everything familiar is actually electromagnetism. Your desk, your body, the air, light, chemistry, life itself, different arrangements of the same force. You're not separate from the magnets. You're made of the same thing. So no, refusing to give a comforting analogy wasn't arrogance, it was honesty. I could have given a comfortable lie. Magnets are like springs. Magnetic fields are like rubber sheets. You would have nodded. You would have felt satisfied. And you would have learned nothing. Instead, I told the truth. The question itself was broken. At the fundamental level, things just are. And our job is not to make them comfortable, it's to describe them accurately. People hated that answer. They called it evasive. They called it a failure to communicate. They were wrong sometimes. The most honest answer is, the universe doesn't work the way you expect. Your intuitions are wrong. And if you want to understand reality, you need to learn a new way of thinking. That's not arrogance. That's respect. Respect for the truth. Respect for the structure of reality, and respect for you, for your ability to handle that truth instead of needing a comfortable fiction. So pick up the magnets one more time. Feel that invisible push. You're feeling one of the four fundamental forces of nature. The same force that makes chemistry work. The same force that lets stars shine. The same force holding you together right now. That's not mysterious. That's magnificent.